Hello, welcome to Guidance Education channel. We are continuing class 12 physics, chapter 2 electric potential and capacitance. Under that we will be doing equipotential surface, shape of equipotential surface for different charge configurations. I am Ananthavalli and I welcome you once again to this video. We have already discussed equipotential surface, its properties with proof. If you have not yet watched that video, click the I button in order to watch that. In this video, we will see the shape of equipotential surface for different charge configurations. First, we will take up point positive charge. For a point charge, we have already seen that the equipotential surface will be in the shape of a sphere, that is spherical. But in two-dimensional diagrams, it looks like a circle. In the center, there is a unit positive charge. I have shown three equipotential surfaces all around this charge. As you can see, two inner equipotential surfaces are closer, whereas the third outer one is spaced a little apart from the second equipotential surface. We need to know why it is shown like this. You already know the relation between electric field and potential difference. Electric field is equal to negative dV by dr. If you need the derivation for this expression, please comment in the comment box. From this expression, it is clear that when dr, the distance of the location from the charge increases, electric field decreases. You can also note that when electric field decreases, electric potential also decreases because you find dV is directly proportional to electric field. So we can surmise that when electric field is weak, the equipotential surfaces will be spaced apart, and where the electric field is strong, the equipotential surfaces will be spaced close together. For a point positive charge, the electric field is directed outward. As the electric field goes away from the charge, the distance between the field lines also increase. So as the distance of the location increases from the charge, the electric field becomes weaker. So electric field towards the outside is weak. In locations nearer the charge, the field lines are closer. The electric field intensity is greater. So where the field lines are closer, the electric field we can assume is very strong. We have already seen that electric field is directly proportional to potential difference. So where the electric field is weak, the equipotential surfaces will be spaced apart. Where the electric field is strong, the equipotential surfaces will be spaced closer. Equipotential surface 1, 2 and 3. Equipotential surface 2 and 3 are spaced apart, whereas equipotential surface 1 and 2 are closer. D2 is greater than D1. You can also notice that the electric field is perpendicular to the equipotential surface. For a point negative charge, the shape of the equipotential surface and the spacing will be the same, but the electric field lines are directed towards the charge. So nearer the charge, the electric field lines are closer, suggesting that intensity of electric field is more there. Away from the charge, the electric field lines are apart, so electric field intensity is less there. So away from the charge, the electric field intensity is weak. So the equipotential surface is spaced apart. Nearer the charge, electric field is strong. So the equipotential surfaces are spaced closer. In both cases, you find D2 is greater than D1. Now let us see the shape of equipotential surface for two equal but like charges. We will consider two positive charges. Two like charges, whether they are positive or negative, will repel each other. For the positive charge, the electric field lines are directed away from the charge. When the two positive charges are aligned as is shown here, they will repel each other and the electric field lines also get repelled. You can see that from the diagram. In the space in between the two charges, the electric field lines are very much separated. Therefore, the electric field intensity is much less. So, the electric field is very weak in that area. Whereas towards the outer side, the electric field lines are more. Therefore, the electric field intensity is strong on those locations. Where the electric field is weak, the equipotential surfaces are spaced away, that is spaced apart. Gap between the equipotential surfaces go on increasing. Where the electric field is strong, the equipotential surfaces are spaced nearer. The gap between the equipotential surfaces is much less. For two negative charges also, the spacing will be exactly similar, but the direction of the electric field will be opposite. They will be directed towards the charge. The shape and spacing of the equipotential surfaces will be the same. Now we will take up shape of equipotential surface for two equal but unlike charges. That is, one charge is positive, the other is negative. This is similar to a dipole. Field lines for positive charge is directed outward, that is away from the charge, and for the negative charge, these field lines are directed towards the charge. So the electric field lines start from the positive, travel outward, and then join the negative charge. Electric field lines are maximum in between the two charges. So it is strong in between the two charges. On other sides, the electric field lines are weak. The equipotential surfaces which are spherical are closely spaced where the electric field is strong, and they are spaced apart where the electric field is weak. So while answering this type of question, you have to consider the direction of the electric field, then draw the equipotential surface and also space them according to the intensity of the electric field. Next, we will consider uniform and non-uniform electric fields. The charges are not shown. Charges are existing somewhere, but due to the charges, the field can be either uniform or non-uniform. First, we will take up shape of equipotential surface in uniform electric field. Uniform electric field means the magnitude of the electric field is same everywhere. It is not changing. That means the potential also is not changing. So when we show the equipotential surfaces, the equipotential surfaces should be perpendicular to the electric field. We say the electric field is perpendicular to the equipotential surface, but the other way also is right. That is, equipotential surface is perpendicular to the electric field lines. The equipotential surfaces should be spaced at equal distances. I have shown here three equipotential surfaces. They are spaced equally. Distance between all the three is the same. Now we will consider a non-uniform electric field where the electric field is increasing in the given direction. Such diagrams are given for the examination. So don't get confused. Since the lines are parallel and equally spaced, you might think it is a uniform electric field. But it is written there, it is increasing electric field. You should notice that. So at the tail end of the arrow, the electric field is weak. And at the arrow head region, the electric field is strong. Okay? Where the electric field is strong, the equipotential surfaces are shown close together. Towards the weak region, the equipotential surfaces have more gap. They are placed apart. Gap between the equipotential surfaces is much less where the electric field is strong. Next one. for decreasing electric field. This is also non-uniform electric field, but here the electric field is weak at the arrowhead and strong at the tail portion. So the equipotential surfaces are closer at the strong region, that is at the tail portion, and apart the gap is more towards the weak region, that is arrowhead region. I strongly believe that you would be now able to draw the equipotential surface with reference to electric field. If the video was useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now. Subscriptions are totally free. And press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.